Welcome back, and here is part 2 of decomposing functions. Let's look at the first one. We have y equals the quantity of 2x minus 5 to the power of 4. So we want to think about how this can be rewritten as parts of functions where they were composed. In other words, one function was evaluated inside of another. So let's start with the outermost function. Look at the overall structure here. It would appear, it looks like it's something to the power of 4. So I'm going to call that function t of x. I'm just making arbitrary letters here. And I'm going to call it something to the power of 4. And actually, I'm going to rewrite this without parentheses. And the reason for that is because typically, actually I'll tell you what, let's do both. So this is really something to the power of 4, or you could think of it as x to the power of 4. It's important to be comfortable with different notations. Now let's look at the inner function. So what appears to be inside this overall structure of something to the power of 4? It looks like it's this linear function, 2x minus 5. So I'm going to call this q of x, and we're going to say that's 2x minus 5. So let's put this together. So the given function of the quantity 2x minus 5 to the power of 4 can be rewritten as the outermost structure is something to the power of 4, and I called that t of x. And then what is going to be what is t going to be evaluating? Well, it's going to be evaluating that 2x minus 5, which I'm calling q of x. So if I were to decompose this, I would decompose it as the t of x function written here and the q of x written there. Therefore, this function can actually be rewritten as a composition of those two functions t and q. And like before, we can check. So if I'm evaluating t of q is really 2x minus 5. So if I do t of 2x minus 5, well, the t function says take whatever you're inserting or evaluating t at and raise it to a power of 4. See, something to the power of 4. So this turns into, well, the something is 2x minus 5. So it's 2x minus 5 to the power of 4. And that is exactly what we were given here. Let's look at the next one. So this says y equals cosine squared of x. Now first you need to realize that this is a notation, a special notation with trig functions. You can actually take trig functions and raise them to powers. So let me first show you how you undo that. So this can be thought of as the cosine of x raised to the power of 2. So, and instead of writing it with grouping symbols, what you can do, and you'll see this with a lot of professors and textbooks, is you write the power of 2 right here, right at the end of whatever your trig function is. So this will work for sine, cosine, tangent, cotangent, secant, cosecant, any of those 6 trig functions. And that power really just means you're taking that trig function and you're raising the whole thing to that power. Now, you might be thinking, well, Stevenson, why would I want to know that? How does that help me? Well, look at what just happened. Hopefully you just recognized that by rewriting it like this, hopefully you can now see what your outer and inner functions are. Go ahead and pause the video at this point and see if you can figure it out before I write it down and show you. Let's see how you did. So when I look at this original function, it might not be very clear to me what my outer or inner function may be. But as soon as I rewrite it like this, I can hopefully clearly see that my outer function is something squared. So what I'm going to turn this into, so now I just have to come up with some names. I'm going to call this g of x. So g of x is my outermost function. It is something squared. Now let's look at the innermost function. Hopefully you can see what's inside the something squared is just a cosine function. Very simple. I'm going to call this one h of x. So now let's put it together. My original function was y equals cosine of x, cosine squared of x. Now how does that get rewritten? Well, my outermost function is g, so I can rewrite this as a composition of g of h of x. And again, let's go ahead and check. So if I say g of h of x, that means I'm doing g evaluated at h. Well, h is cosine. So what this says is I'm going to take cosine and evaluate it input or substitute it into the g function. Well, the g function says whatever you evaluate into g, you have to just square it. So this is something squared. But if you remember, we can rewrite this in a very cleaner, a much more efficient notation. And we would rewrite it like that, which is exactly what we were given.